All right, so for Unit 4, we're talking all linear equations. And a lot of you guys remember how to graph this in slope-intercept form. We kind of reviewed that at the beginning of the year. But I kind of want to take a couple steps back and start with the basics. And so in this video, we're going to look at x and y intercepts and graphing with those, as well as an input-output table. So first, let's just talk about what are our intercepts. So an x-intercept is simply where it crosses. And when I say it, I mean the function crosses the x-axis. And something that's really important, something that's very important here, is that for an x-intercept, okay, it always looks like this, x comma 0, always, okay? For your y-intercept, it's simply where it crosses the y-axis. And also, what's really important is your ordered pair always looks like this, 0, comma, y. Okay, we'll kind of come back to that. And then zeros are simply the value for your input when the output is simply 0. Okay, and so an example of all this, okay, so if I were to have a graph, right, and let's say we got, 1, 2, 3, 4, 1, 2, 3, 4, and I'm going to put my line in here, so let's say there's a point there, and there's a point here, okay, so it's crossing, terrible straight line, but you kind of get the point here, right, and so I can see that my y-intercept, is right there. Oh, geez, hold on. Let's try that again. That's not my x-intercept, that's my y. My x-intercept, right there. My y-intercept is here. Okay, now for my zeros, a lot of times I'm going to calculate that separately, but that is also, okay, your x-intercept. So let's start with graphing using an input-output table. So I'm going to zoom up on this first example here. Whenever we're using an input-output table, I usually like to use the same 5 numbers. And those numbers would be -2, -1, 0, 1, and 2. Because what that does is it kind of gives me a picture of what the left-hand side looks like of the graph, those negatives, and what the right-hand side looks like, so the positives. And so all I'm doing is I'm plugging in each value in for x and evaluating the outcome. So I'm plugging in -2, I'm plugging in -1, 0, 1, and 2, and so forth. Okay, and so often we'll just kind of do all that in my head. So when I plug in -2, that gives me an outcome of 9, because negative times negative, positive 4, plus 5 is 9. When I plug in -1, that gives me 2 plus 5, which is 7. When I plug in 0, I get out 5. When I plug in 1, I'll get out 3. And when I plug in 2, I'll get out 1. And so now I can go ahead and plot these points. So -2 and 9 is going to put me right here. There's my first point. -1 and 7 is right here. 0 and 5, 1 and 3, and finally 2 and 1. And because I know that this is linear, I can go ahead and connect the points. And let's see. Now for my intercepts, I can clearly identify the y-intercept. I see that that's at the point 0, 5. However, I don't know the precise location of my x-intercept. So in order to do that, what I'll do is I'm going to plug in 0 for my y. And remember, f of x is the same thing as y. Okay, so I'm just going to show all my work here. So what I'm going to do is I'm going to take out f of x. I'm going to replace it with 0. And then I'll go ahead and solve. I'll subtract 5. That gives me -5. Then I'll divide by 2. Oop, running out of room here. Divide by -2. And what that gives me is positive 2.5. So that would be my x-intercept. Or rather, it would be 2.5 comma 0. And so that's also considered my 0. What did I plug in to get out 0? I plugged in 2.5. So for part B, same idea. Plug in the same 5 numbers, -2, -1, 0, 1, and 2. So when I plug in -2, let's see, that gives me -6 minus 7. Okay, so that's going to give me -13, When I plug in negative 1, I'll get negative 3 minus 7, so that's negative 10. When I plug in 0, I get out negative 7. And when I plug in 1, I'll get out negative 4. And finally, when I plug in 2, I'll get out negative 1. And so now I can go ahead and plot those points. And just in case you were like, where am I getting those points? These are ordered pairs. Remember, ordered pairs are inputs and outputs that create an x and y coordinate. So negative 2 and negative 13 kind of go off the graph. So it sits somewhere down here. We kind of went off a little bit. That's okay. Then I have negative 1 and 10. Then I have 0 and negative 7. 1 and negative 4. Finally, 2, negative 1. Okay. So again, I have my straight line, and I can identify my y-intercept very clearly. That's at the point 0, negative 7. Unfortunately, my x-intercept's a little bit more complicated. So I'm going to take that f of x is equal to 3x plus 7, or sorry, minus 7. And what I'm going to do is I'm going to replace the f of x with 0. What did I plug in to get out 0? And so I'll add 7. I get 7 equals 3x. Divide by 3. And I get x is equal to, now it's going to be a repeating decimal, but it's 2.3 repeating, or you can say 2 1/3. So my x-intercept is at 2.3 comma 0. So on our next page, we are going to look at like, well, how could we also just graph by using x and y intercepts? And so for example A, to find my x and y intercepts, all I'm doing is plugging in zeros for one or the other. So what I like to do is I'm going to split my kind of screen in half. So this is how I find my x-intercept, this is how I find my y. So to find my x-intercept, I plug in 0 for y, and essentially you should still have the variable that you're trying to solve for, which is x in this case. So I would go ahead and add 10, and that gives me 10 equals negative 2x, then divide by negative 2, and so x equals negative 5. But that's the point, negative 5, 0, right? Remember f of x, same thing as y. Now to find my y-intercept, what I'll do is I'll plug in 0 for x. So I get y is literally, this cancels, y literally equals negative 10. So this would be 0, comma, negative 10. Now if I had a graph, all I'd have to do, if this was my graph, so let's see, I'd have 1, 2, 3, 4, 5. Let's pretend like this goes all the way to negative 10, okay? 2, 4, 6, 8, there's negative 10. All I'd have to do is plot those 2 points and connect them. So that's the purpose of graphing with x and y intercepts. So let's try part B. So again, I'm going to split my screen here. Here's my x-intercept, here's my y. So to find my x-intercept, I'm going to plug in 0 for y. Now notice, really nice, how this just cancels. That's just 0. So now I'm literally just left with 4x is equal to 18. Divide by 4 and x equals 9. So I have the point 9, 0. And then for my y, same thing. I'll put in a 0 though for x. And again, this just cancels. But don't forget, don't drop that negative in front of the 9. So I have negative 9y is equal to 18. And so y equals negative 2. So that's the point 0, negative 2. Now when we find these x and y intercepts, they have a meaning. So we're going to put a story behind this. So in this example, it says a box of peanuts is poured into a bag at a rate of 4 ounces per second. The table shows the function relating the weight of the peanuts in the box to the time in seconds. The peanuts have been pouring out of the box. So determine the x and y intercepts from the table. So if you can kind of see my example B up above. Okay, notice we've got this pattern here. We've got zeros as part of our ordered pair. So I see 2 of those, right? I see a 0 in for x there, and I see a 0 down here for y. So if x is 0, that means that's my y-intercept. And if y is 0, that means that is my x-intercept. Okay, so what does that mean? Okay, so the y-intercept is my starting place. So I would say in this case, my y-intercept, what that means is where the box weight, I suppose, started. Not a whole lot of room here. And then the x-intercept, kind of like the opposite, x-intercept represents, let's see, how long it took to empty, because at that point the weight is 0. So same thing we're going to do, but just now in a graph. It's a little easier to identify. Like here's my y-intercept, and down here is my x-intercept. So my y-intercept, let's see, what are we comparing? We're comparing minutes and the amount of water, probably in a pool. So we're draining it, right? So the y-intercept at this part means that this is where the pool, we'll just say pool in this case, had max or most water, okay, or where it's kind of like started out. And then my x-intercept, okay, that just represents how long it took to drain. So how long it took to fully drain. Whoop. Okay, so in this case, it took 4 minutes to drain. And over here, we started at 200 gallons of water. So again, it's just telling me that story, kind of like Unit 3. So down here, now we're going to actually calculate those x and y intercepts. And like I kind of showed you above, we're going to actually graph. So I want you guys to try and use that trick, okay, in finding your x and y intercepts. So this is going to be my x-intercept. Actually, I'm going to draw this differently so it's not so confusing. So we're going to put our x-intercept over here and our y-intercept here. So when I'm calculating for my x-intercept, simply cover up the y. Okay, so now you're literally left with 4x is equal to 4. Okay, so 4x equals 4. And so x equals 1. And so that's my coordinate right here, 1, 0. And then for my y-intercept, okay, I'm going to cover up the x. And I literally have y is actually just equal to 4. So I get y equals 4. And the reason I can do that is because I'm plugging in 0 for x or I'm plugging in 0 for y. So it just kind of disappears. So my y-intercept here, 4. And all I have to do is connect those points. And finally, b. Okay, we have a fraction, our favorite, I know. So x-intercept, y-intercept. Okay, so if I'm finding my x-intercept, that means I'm essentially going to cover up my y. I'm left with 1/2 x is equal to 3. So I'm going to write that. So I've got 1/2 x is equal to 3. And remember how we solve an equation with a fraction? We multiply by its reciprocal. That cancels. And so x is equal to 6. So here we go. Here's my point on the x-axis at 6. And then for the y-intercept, I'm going to cover up the x, but I don't notice how I'm not covering up the sign in front of the 3. So that means I'm left with -3y is equal to 3. Divide by -3. And so I get y is equal to -1. So I put the point -1 on the y-axis and connect my points. And that's it.